So mixed number subtraction poses a problem because if this was addition, 1 plus 5 would make 6. But this is subtraction, and we can't take 5 away from 1. So my recommendation for all of these, and you could do this for mixed number addition as well, my recommendation is going to be that you convert these things to an improper fraction, then do the operation, then convert them back to a mixed number. So 8 times 4 is 32 plus 1 is 33. We retain 8 as our denominator. 8 times 2 is 16 plus 5 is 21. And again, we retain 8 as our denominator. And 33 minus 21 is 12. So that's pretty easy. We retain 8 as our denominator. And we do need to then take this improper fraction and convert it to a mixed number. So 12 over 8, I look and I see 8 goes into 12 one time with a remainder of 4. And so we have to be careful here because Wolfram won't like that, because that 4 over 8 is not in simplest terms. If I was to look at 4 over 8 independently, they are both divisible by 4. And so that in simplest forms is going to be 1 over 2. And so 1 and 4 over 8 is equivalent to 1 and 1/2. Again, Wolfram is a super useful tool here. The way to put this in there is to say 4 and then the and sign, 1/8, minus 2, and then the and sign, 5/8. You'll see that the input as it's interpreted is here. The exact result is there. The mixed number, like what we wanted, the 1 and 1/2, is right here. All right. Next, we are going to have 9 and 1/10 minus 1 and 7/10. Now, similar to the last one, I cannot take 7 away from 1, so I'm going to use the G method to convert these to improper fractions so that I can do the subtraction. And I'm going to get 10 times 9 is 90, plus 1 is 91 over 10. And on the right, 10 times 1 is 10, plus 7 is 17 over 10. 91 minus 17 is going to be 74 over 10. So converting that back, 74 over 10 into a mixed number, 10 goes into 74 7 times with a remainder of 4 and a value of 10 there. I am noticing also that 4 over 10 can be reduced, can be simplified. And so I'm going to divide, they're both divisible by 2. And so I'm going to get 2 over 5 as the equivalent fractional part there. So 7 and 2 over 5 is where we would end up with that one. Again, going to Wolfram to use as a tool to help. 9 and 1/10 minus 1 and 7/10. So again, I get an exact result of 37 over 5. Mixed number here is going to be mixed fraction is what I'm looking for. 7 and 2/5, which matches our work. Okay, we have 9 and 1/4 minus 1 and 3/4. So again, converting both of these to an improper fraction using the G method. I'm going to have 4 times 9 is 36, plus 1 is 37, over 4, minus 4 times 1 is 4, plus 3 is 7. 37 minus 7 is going to be 30. We keep the denominator of 4. So then converting that 30 over 4 to a mixed number, we see that 4 goes into 37 times with 2 left over. Because 7 times 4 is 28. I've got 2 more to get to 30. And then I see again that fractional part of our answer, 2 over 4, can be simplified. But 4 and 2 both have a common factor of 2. 2 divided by 2 is 1. 4 divided by 2 is 2. So this is going to be equivalent to 7 and 1/2. Did we already do that problem? No. Good. Okay, and again with Wolfram, 9 and 1/4 minus 1 and 3/4. As a mixed fraction, I get 7.5, which matches what we came up with. Last one for this round, 8 and 1/6 minus 1 and 5/6. So again, converting both of them to an improper fraction using the G method. Six times 8 is 48, plus 1 is 49 over 6. 6 times 1 is 6, plus 5 is 11 over 6. 49 minus 11 gives us 38 over 6. We'll convert 38 over 6 to a mixed number by division. 6 goes into 38 6 times with 2 left over. And so I do see that the fractional part of this, which is 2/6, not 2/5. 2 and 6 are both divisible by 2. So 2 divided by 2 is 1. 6 divided by 2 is 3. That's equivalent to 6 and 1/3. One more time, getting Wolfram to do this to check our work. 8 and 1/6 minus 1 and 5/6. Mixed fraction is 6 and 1/3, which matches what we got. That's it for this one. Mixed fraction subtraction is a bit of a pain.